So I'm going to do something today that I think will be extremely popular. For today's lesson, we're simply just going to start going over questions right off of your assignment. You're going to be getting free answers, a quick explanation. I'm going to do this for this lesson and the next lesson because these are just pretty straightforward methods, techniques that you're going to learn. So question one, let's do this together. Solve this system using substitution. Now, a lot of times you'll see a little brace right there, but it's not necessary. So we learned in our last lesson that both of these are lines that you should be able to graph the first line. I'm just kind of randomly drawing a line here. And then we should be able to graph the second line. And I don't know exactly what these lines look like, but on the graph paper, if we graph these two lines, the point where they intersect is called the solution to the system, or the solution of the system. Well, in today's lesson, we're going to look, is there a way to do this? Is there a way to find where these two lines intersect without using any graph paper? Is there a way to do it algebraically? Well, and you can see, yes, there is. Today we're going to learn this method called the substitution method. It does not require graph paper. Now, I'm going to tell you right off the bat, the substitution method does work the best if at least one of your lines is in the y equals form. Okay, so here we have this line's in the y equals form, this line's in the standard form. The substitution method works great. It's the best method if at least one of your lines is in the y equals form. So here's how it works. We're going to put parentheses. We're going to take our line that's in the y equals form, and we're going to put parentheses on everything to the right of the equal sign, the 5x minus 3. And then we're going to draw an arrow from those parentheses down to the y below. So here's how the substitution method works. We're going to write out this line in standard form, the 3x minus 2y equals negative 8. But we're going to remove the y. This y, we're going to remove it. And in its place, we're going to substitute what's in the parentheses, 5x minus 3. Now, why are we allowed to do this? So this line right here literally says that 5x minus 3 is equal to y. That means the variable y and the expression 5x minus 3, they're interchangeable. They're equal to each other. So for that reason, you're allowed to take this y away and replace it or substitute it with its equivalent, 5x minus 3. This is kind of similar to like if you had a substitute teacher. Imagine that y is the teacher, but the y has to take off sick one day. Well, what would happen is that the y, the teacher, would be replaced by a substitute. The substitute would come in and take the y's place, just like we did in this step here. Okay, now we'll find that this works really well because an equation that has two variables, an x and a y, is impossible to solve all by itself. Okay. However, look at what our replacement is now. In our replacement equation, now the y is gone. All we have now are two x's. And since there's only one variable in this equation, we can go ahead and solve for the x. Just like we did in Unit 1, we're going to solve for an equation, to solve for an x. We're going to start with the distributive property. So negative 2 times 5x is negative 10x. Negative 2 times negative 3 is positive 6. Okay, 3x minus 10x is negative 7x. Combining those like terms together there. And then I can solve for x in two steps. I would subtract both sides by 6. And then I'm going to divide both sides by negative 7. And I get this first answer, x is equal to positive 2. Now, remember that when you solve a system of lines, you're trying to find the point where the two lines intersect each other. Well, this is the x-coordinate of that point. We're going to type that into my first box. That's going to be my first answer. But to find the entire solution, we also have to go back and find out what the y-coordinate would be equal to. The way we're going to do this is we're going to take our first equation that was in the y equals form, and we are simply going to take our x value of 2, plug it back into that first equation in the y equals form. That'll leave me with y equals 5 times 2 minus 3. And then it's easy to calculate y. Y would just be 10 minus 3, which is 7. So 7 is my y coordinate. And this is my final answer. That's what I'm going to submit on my assignment. And just if you're a visual learner, think about what you're doing. The point where these two lines cross is right here. It is at 2, 7. But with this technique, we do not need graph paper to figure that out. Now we're not going to do all of question 2 together, but just a quick note for you. If one of your equations is actually in an x equals form instead of the y equals form, all that would change, you would still put this 3y minus 1 in parentheses, but what would change here, instead of drawing an arrow down to the y, here we would draw an arrow down to the x. In this case, we would take this x away and replace that x now with the 3y minus 1. So it doesn't necessarily have to be in the y equals form to use the substitution method. You could also do this if it was in the x equals form. You could also do this with different variables as well. If it had like an a or a b, it doesn't really matter. All right, and then we're going to end by going over question 9. So my question is, how would we know? Sometimes, remember, two lines could be parallel and they never cross and they never have any solutions. Likewise, sometimes the two lines can be identical to each other and they can have infinite solutions. How do we know the difference between the two? And what's this going to look like with the substitution method? So here I have y equals x plus 2. I'm going to put parentheses around the x plus 2 and then draw an arrow down to the y below. So this negative 3x plus 3y equals 6. I'm going to take that y away and I'm going to replace it or substitute it with x plus 2. So using my distributive property, I would have 3x plus 6. And then when I combine like terms, something unique happens in this particular problem. Negative 3x plus 3x, that's a 0x. Or you could even say that that term has just vanished altogether. 0 times anything is just a 0 or nothing. Well, look at what I'm left with. In this particular case, if you ever do the substitution method and kind of both of your variables cancel out, your y vanishes and your x's cancel out, you look at what you're left with and you have to decide if this is a true statement or a false statement. Here, 6 equals 6. This is a true statement. So we're going to say infinite solutions. These two lines are identical and they have an infinite number of solutions. If the only way you would know that these two lines would be parallel, if you ever had a statement that was false, like 0 equals 6, a false statement, that's how you would know those two lines are parallel and they have no solutions. But here, this statement is true, infinite solutions. Okay, so I hope this was good help getting you started on this assignment. Best of luck to you finishing this up. Take care.